Hey guys, today we're going to be talking about ocean convection currents. And please bear with me, I'm using a screen recorder and it's like lagging on my computer. So just if it lags or if it's slow, just bear with me. But our standard is gather evidence to justify the oceanic convection currents are caused by the sun's transfer of heat energy and the differences in salt concentration leading to global water movements. So, what does that mean to me? The ocean's currents are caused by mass amounts of salt and the sun's heat energy. When the sun transfers heat energy to the ocean, the warmer water rises and the colder water sinks to the bottom. A good example of that would be if you've ever went swimming and you've gone in the pool and the shallow end feels really good and it's warm and everything, but then if you dive to the 5 foot or if you dive to the 10 foot even, the water gets colder. Well, that's because whenever the sun transfers the heat energy, the colder water is sinking to the bottom, but the warmer water is rising. So, and the same goes for salt concentration. The water with the high salt concentration will sink further down because it has more density. And I was going to click on the link, but it has not been working, so I'm just going to go over here and play it through this.
In this video, we will use this container, some salt, food dye, in order to help understand ocean currents caused by differences in salinity. Many of the waves on the surface of the ocean are caused by the wind. However, underneath the surface, there are deep currents that are caused by density differences, caused by differences in salinity. This demonstration will help you understand how these currents occur. So we're going to show how differences in salinity can cause currents. On this side, we're going to have very salty water. In fact, we're going to go ahead and pour some salt into it. There's 1, 2, 3. Let's go one more. 4. Okay. And then on this side of the container, we have fresh water. So I'm going to stir this up real fast. And then what we'll do is there's a divider in between. And when we open up the divider, we'll see if there's a current. Okay. So here we go. We'll open it up and you can see the green, more
and notice, he's probably already going to say this, but notice how the fresh water is rising more to the top and the water with the high salt concentration is staying at the bottom.
Salty water flow underneath the fresh water because it has a greater density. And you can also see the fresh water flow above the other. So I'm going to stop the flow now. And now what I'll do is I will add some blue food coloring and make this side, which is a mixture of both, really turn it blue. And then what we'll do is we'll open it up again and see if it settles in between these two. Okay, so anyway, let's look at this real fast. We have fresh water, then we have more dense salt water, then we have a mixture, we'll call that brackish, and we'll see if it should settle in between. Again, we're trying to see how the water flows due to differences in salinity.
And what do you all think it's going to do? Do you think it's going to rise to the top because he has still the same amount of salt, maybe? Or do you think that it's going to or rise to the bottom because it has the same amount of salt? Or do you think it's going to rise to the top because he added food coloring? Or do you think it's going to stay in the middle? What do you guys think?
So we'll open it up. And as you can see, there's a nice current of, we'll call it brackish water. Again, we have also a convection current flowing this way, and we'll stop it. And as you can see, we have fresh, brackish, and salt water. I hope that helps in your understanding of convection currents.
Okay, guys, and that is a great example of how the salt concentration works in the ocean. And plus, I mean, you can think of that as warm water up at the top and the really cold water at the bottom, and then the lukewarm water in the middle. That's how it's also is the same for the sun's transfer of heat energy. And I hope this has helped you all learn more about ocean currents.